So this is Pithoprakta from Iron Ether. It's 8 trigger or gate outputs selectable on this switch and a CV output. We've got a clock input, reset input, CV over both probabilities, and a loop gate to turn loop on and off, which is also on a switch, a loop length, and a CV and an attenuator for the loop length. We've got a reset on the button as well. We've got a divider switch, which turns output 1 and 2 to be divide by 2, 3 and 4 divide by 4, 5 and 6 divide by 8, 7 and 8 divide by 16. Now you may think, well, why not have different divisions on each output? And this is because in divide mode, output 1 will be the sort of on beat of that rhythm and 2 will be the off beat. So rather than having a switch like some dividers do for mathematical or musical division, we get both. So if 1 was my 4 to the floor sort of techno kick, number 2 would give me that offbeat hi-hat. They'd play against each other. And this applies for all division. In the normal mode, these are separate outputs. The basis of the module is that these gates or triggers are probability based. But we don't get probability per output. We have a probability for output 1 and a probability for output 8. Now I'll pull up a graphic from the manual, which is well worth a read and a look, by the way. We can select the sort of range of probability. With probability down at 0 on 1 and full on 8, there's 0 chance 1 will output a gate, 100% chance that 8 will output a gate, and this probability would ramp down between the outs. So going the other way, 1 would definitely play, 8 definitely wouldn't, and as we go through those outs, we'd sort of cycle down towards no probability. We could have half probability that this will fire, that would go down to 0, or we can have these custom ranges and CV those. It's a really powerful module. Let's listen to a drum beat that's just going to set the clock and pace for everything that's going on in the patch. I'm going to add my clock. So let's plug in some outputs, which are just going to different drum modules. You can see these are firing, this one isn't. We can weight that differently. Now we can loop this and change the loop length. While this is looping, these two probabilities become a probability of change. So all the way down, and this is why I turn them down, nothing is happening. It's a straight loop. But if I turn it up, this is the probability that new data will enter the loop. You can hear we've now got a different loop. Let's try that again. So there's my loop. Let's add a chance that more data will come in this side. The output's nearer 8. That's now in the loop. As I said, we can actually gate to the loop on and off, or do it on the button. We can CV the length. Let's check out the divide mode. Let's plug some sounds in. And then these divide down. Now this probability still works in divide mode. Let's just spread these out a little bit. But they're still dividing down. Again, we can loop this. I've got a bass sound set up, and I'm going to use this CV output to move the pulse width of a square wave, or pulse wave, that's going into a filter, and also move its cutoff. So let's patch in my sound, take the CV out. So this CV out is what you're hearing modulate the bass. I'll take these out. The more gates that are firing, the more information the CV's got to work with. And again, we can loop that. In trigger mode, you can hear these little triggers stack up. It's not really enough to give us useful information. The CV out works much better with gates. Let's plug the sounds back in. Let's just plug an unsynced LFO into the loop gate. And another unsynced LFO into the loop length CV. So without the CV, you heard a short loop triggering almost like a beat repeat effect. With CV in the loop, we're triggering the loop on and then changing how long the loop is. So we've got a varying loop, as opposed to the sort of endless variation that non-looped probability-based outputs give us. Can reset. Let's do this in divide mode. Taking these out, we can use these for the probability. So 0 probability, let's add an LFO to probability 1. So as this is an LFO, we should set this in the middle, and then this can swing both sides. We can do this with probability 8 as well. But because this is probability based, we're actually fading in the intensity of the sort of random rhythm this is giving us. We're not fading in a defined pattern. So let's set these in the middle somewhere. And then add some CV. We can loop this still. So it's a massively powerful unit. As you've heard through this, I've been using drums just as a basic example. This could be firing off gates to sample and hold, sequencers, envelopes, resetting LFOs, anything that's going to take a sync input or a trigger or a gate. Let's set up a couple of synth voices and use these gates to fire off the envelopes in the voice and listen how we can get different sounds and tones and rhythms by firing these off at different points. So for this patch, I wanted to show how you could get creative with a basic synth voice. I have 2 oscillators mixed into a filter, slight bit of detune, and there's an envelope triggering a VCA that's just firing in time with the clock in this particular patch. So the first thing we'll do is take one of these outputs and fire off a gate into a second envelope, which is going to modulate my filter. could also take an output directly into the filter, so that gate output, any of these, is going to push open the filter. Let's remove that for now. Let's add one going to resonance. Move to gates. The resonance is different. Let's patch back in one to the filter. We could also change what's clocking our sequencer to be one of these steps, so that each step in the sequence changing pitch changes as well. Let's change the resonance to be the CV out. Let's actually take a gate output into the FM input on one of the two oscillators going into the filter. I fine-tuned the FM input amount, and hopefully this is going to push it up a fifth. So when the gate fires on this cable, we're going to get a harmony, a fifth interval between the two. Let's loop it. So that's been a really quick and quite creative way of letting random dictate something musical that we can then capture and repeat through a pattern. If I'd have had all the control voltage needed for this, separate gate outputs, different sequences for the CV input, and changing pitch sequences to get these intervals, I might not have done it the same way and the outcome may be different. Let's take off loop and play around. It's a great way of expanding a basic synth voice as well. To end on, let's check this out at audio rates, because we can clock this thing up to about 1 kHz. So let's check out the Pithoprakta at audio rate. I've got a square wave coming into channel 1 on the Modax data. This is the green line on top. Not perfect square, but doesn't really matter. Taking the buffered copy out, I'm going to patch that into the clock in on the Pithoprakta. Just turn probability down so it doesn't fire off straight away. I'm taking output from gate 1 into channel 4, and then we're listening to the output of that. So to turn up probability, even though this is an audio rate, more of those high and low signals in the square are going to come through. Like audio rate random gates. Up full, where we've got 100% probability, we'll get a stable pitch. Triggers don't work up at this rate. We could use the divide to create subs. Turn up my rate. But I'm going to stick in the normal mode. I'm just thinking, alright, great, audio rate clock and an output that follows it. We can use the loop to create interesting variations and glitches. So if I hit loop and just jam on the probability, notice within this loop, changing the length, we've got different probabilities, different rhythms if you like. So let's throw some CV at the length and we'll be able to introduce these bits of glitches as we go along. Just going to going to take a random unsynced LFO. Let's make this bipolar. So fine tune this. This will follow the audio rate clock. So if I sweep my oscillator, that's my clock source, just going to set up a basic quantized minor arpeggio type thing by throwing some sample and hold into a quantizer. Should take this down, speed up my sample and hold. And this is the output that we're listening to. Let's introduce some probability that's not 100 and turn loop off. Just pitch up a bit. CV the probability. Take another couple of unsynced random LFOs into loop and loop CV. It's great for sort of chiptune and glitchy square stuff where we're introducing noise, looping the noise, looping these different probabilities and changing the length of those loops. It's really powerful in the system, big or small, drums, synth systems, clocking your modulations, sequences, anything that looks for a rising edge, be it a gate input, trigger input, sync, reset. Really great device, and that loop makes it really musical and recallable, and it allows you to go from non-random, we just say a looping 8-part sequence, to just introducing new values. It's a really powerful unit. Hit like and subscribe for more videos every week, and check the Patreon link below if you want to support my channel.